Hey guys, it's Miss Caps here, and today we're looking at a numberless word problem. So I'm going to read that now, and I want you to think about which operation would we use to solve this numberless word problem. Would we add, subtract, multiply, or divide to solve this? So we have Mandy rode her bike for several days. Each day she rode some distance. What was her total distance at the end of several days? So we're missing some information here. So we're not actually going to solve this just yet, but I want you to think about the problem. So it says Mandy rode her bike for several days. We don't know in this problem how many days she rode her bike, but we know she rode her bike for several days. And each day she rode some distance. Again, we're missing the some distance that she rode. And we're going to be looking for the total distance at the end of several days. So I want you to think about right now, how would you solve this? So again, we know that we have some distance, and she rode some distance for several days. So if we were representing this with a bar model, we would take our some distance and put it into our larger bar for however many days, we don't know, but however many days she rode her bike. So if you said we're going to solve this using multiplication, you are correct. We are going to now be solving some multiplication problems that are involving our fractions, multiplying fractions that we've been working on. So we're going to tie that in with some word problems. So now we're going to look at how we would solve this problem if we do put some numbers in there. So we have Mandy rode her bike for 4 days. Each day she rode 3/4 of a mile. How many total miles did she ride at the end of those 4 days? So now we can see she rode her bike for 4 days, and each day she rode for 3/4 of a mile. So if we represent this with the bar model, it looks like this. So we have day 1, day 2, day 3, day 4, and each day she rode 3/4 of a mile. So we have 3/4 in each of our boxes. So our multiplication problem is 4 times 3/4. So we're looking for the total number of miles that Mandy rode. So Mandy rode some total number of miles. So when we solve this, I'm going to click over now to this screen. So I have this set up for us. I have 3/4 times 4. And if you remember from a previous video, when we multiply, we set that fraction up 3/4 4 times. So we're doing 3/4 times 4, okay? And when we come over to our workspace, you've learned that you can set that 4 up as a fraction, okay? You can set that up as 4 over 1, and you can multiply across. Well, 3 times 4 is 12. 4 times 1 is 4, okay? So we could say that Mandy rode 12/4 of a mile, but we're going to take this fraction now and we're going to turn it back into a whole number or a mixed number. So you've also learned that fraction line is can also mean division, okay? So to solve this, to put it back into a mixed number or whole number form, we need to divide 12 divided by 4, okay? And with 12 divided by 4, if we skip count up, we have 4, 8, 12, well, 4 goes into 12 evenly, okay, and we skip counted 3 times. So 12 divided by 4 is 3. So if we go back to the problem, Mandy rode 3 total miles. Okay? Now we're going to look at this problem. Same scenario, just change the numbers, okay? So this one says, Mandy rode her bike for 6 days. Each day she rode 7/8 of a mile. How many total miles did she ride at the end of those 6 days? Okay, so same setup here, just different numbers. We have days 1 through 6, and each day she rode 7/8 of a mile. Okay, so our multiplication problem is going to be 6 times 7/8. 6 times 7/8. So we're going to click over and solve that problem. Okay, so let me clear this out from our previous problem. Okay, guys, had some technical difficulties, but as you can see, we're multiplying 6 times 7/8. So I've made my groups there to the left, but we've learned that you can put a 1 under the 6 and simply multiply across. So 6 times 7 is 42, and 8 times 1 is 8. So what we're doing is dividing to get this in mixed number form. So 42 divided by 8. We have to solve that to break this down to a mixed number. And I like to skip count by 8 in this case to get to as close as I can get to 42 without going over. So I can start with 8, 16, 24, 32, 40. Well, if I get to 48, that's going over. So the closest I can get is to 40, okay? And that's skip counting 5 times. So 8 times 5 is 40, so 5 becomes my whole number. Okay? And then I have to take that 8 times 5, well, that's 40. This 42 minus 40 leaves me with 2. And my denominator stays the same. Stays at 8. So my answer is now 5 and 2/8. Can also simplify that down into 5 and 1/4. Okay? So either of those answers is correct. If I click back over now, okay, have that 6 times 7/8 is 5 and 2/8. So Mandy rode 5 and 2/8 miles total. Again, you could simplify that down into 5 and 1/4. So today's assignment has you solving this problem. I'll read the numberless word problem for you, but then you'll solve it with the numbers filled in for you. So it says a polar bear walked for several days. Each day he walked some distance. What was the total distance he walked at the end of several days? So same thing that we just did, guys. You're going to plug those numbers in and solve that problem. You have the same word problem twice, but the numbers are different. Okay, so I hope that you enjoyed this lesson, and I know that you'll do great with today's math.